Identity axioms. Identity is so basic that it is almost difficult to see it as a particular theory. However, to make inferences about identity, we do need some special assumptions, axioms. Think of a person or a computer that doesn't know what this identity symbol means, has never seen these two vertical lines on top of each other, has no idea what it means. Well, then look at the axioms. That tells what it is. If you don't know what identity means, the axioms tell you what it means. At least to the extent that is needed in deductions. The first axiom, for all x, x equals x. This simply says that we think of everything as equal to itself. Second axiom, for all x, for all y, x equals y implies y equals x. This means that we think of identity as symmetric, a symmetric relation. Third axiom, for all x, for all y, left parenthesis twice, x equals y and y equals z, right parenthesis, implies x equals z, right parenthesis. This is the transitivity of identity. If x is equal to y and y is equal to z, then x is equal to z. The fourth axiom, for all x, for all y, left parenthesis twice, x equals y, and Pnx, right parenthesis, implies Pny, right parenthesis. This says that the predicate Pn, just an arbitrary unary predicate in our vocabulary, must be closed under identity. This is obviously the case in models if Pn is interpreted as a subset of the universe and the interpretation of x is in this subset, then of course the interpretation of y is also in that set, because the interpretations of x and y are the same. The fifth axiom, for all x prime, for all y prime, left parenthesis twice, x equals y and x prime equals y prime, and Rn xx prime, right parenthesis, implies Rn y prime, right parenthesis. So this says that the binary predicate Rn is also closed under identity. Pretty reasonable. If the pair xx prime is in Rn, then so is the pair y prime, because it is the same pair. So these are the identity axioms. Whenever we are making deductions about formulas which include identity as a symbol, we can use these. Otherwise we don't get anywhere. They form the theory of identity, in a sense the most general theory that one can really think of. Here are some other formulas about identity that can be derived from the identity axioms. First, for all x there exists y such that x equals y. Everyone is someone. Pretty obvious. But if you don't know what identity means, you have to prove even this. And this can be derived from the identity axioms. The second example, this is a bit more complicated. This is like I4 and I5, but for an arbitrary formula A. So we assume that the variable yi is free for the variable xi in A for all I. Then this says, for all x1 to for all xn, for all y1 to for all yn, left parenthesis, x1 equals y1 and so on, and xn equals yn, and A, right parenthesis, implies A, y1 slash x1, and so on, yn slash xn. So if we know A, and we know these identities, then we can derive the substitution instance wherein A, yi is substituted to the free occurrences of xi. Intuitively this says that identical elements can be substituted for each other. pretty reasonable. But this can actually be proved by induction on A. For the atomic case, when A is Pn or Rn, this is already the axiom I4 or I5, but then we have to prove inductively this for all A. It's not difficult, but there's a little bit of work. Next formula. Exists x for all y x equals y implies for all x for all y x equals y. Intuitively, this says that if there is just one element in the universe, then any two elements are equal, namely equal to the one that constitutes the whole universe. This can be derived from the identity axioms with a few lines. The last example. We try to express that if there are just two elements in the universe, then of any three elements, two must be equal. Let's see how this goes. Exist x, exist y for all z, left parenthesis, z equals x or z equals y, right parenthesis, implies for all x, for all y, for all z, left parenthesis, x equals y or y equals z or x equals z, right parenthesis. So if we have just two elements, x and y, in the universe, then if we take any three elements, x, y, and z, then two of them must be equal. Note that the identity axioms have been written with certain bound variables. Here they are. Like I1 is written for all x, x equals x. But we can derive very easily from this for all y, y equals y. I mean, it's just two lines.